All right, we are going to graph this exponential function right here, y equals half times 5 to the x power. Now, there's little tricks that you could use to graph exponential functions, but what I'm going to do is I'm going to make myself what's supposed to be a t-chart. Looks terrible. But what I'm going to do is I'm going to substitute in 0 for x, 1 for x, figure out a pattern before I even bother with these guys right here. Now I'm going to plug in 0 for x. I'm going to do that a little bit mentally, but also write a little bit off to the right. So if I plug in 0 for x, that's going to be 1/2 times 5 to the 0th. Anything to the 0th power is 1. So that gets me half of 1, which is a half. So plugging in 0 gets me a half. Now, a trick that we can learn here is whenever you plug in 0, whatever number is being multiplied to our power, that's going to be your y-intercept. Fun fact. All right. As long as you're not adding anything over here. Don't want to screw that up. Now, let's plug in 1 and see what happens. Okay? If I were to plug in 1 for x, 1/2 is still lingering. 5 to the first power is just 5. Okay? That ends up with 5 over 2, which is 2.5. Now, the pattern that we're figuring out, right, is as x goes up by 1, my fraction, or whatever number this is going to be multiplied by 5. So the next guy is going to be 25 over 2, because as x increases, y gets larger by multiplying it by 5. 5 over 2 times 5 is 25 over 2. In reverse, as I lose an x value of 1, this guy divides by 5. So if I were to take 1/2 and divide it by 5, that's the same thing as multiplying it by a 1/5. That gives me a 1/10. So that allows me to draw a few points. So -1 is basically 0. I mean, 1/10 is close enough to 0. 0 1/2. 1 2/5 is 2.5. 25 over 2 is 12.5. And if I were to multiply by 5, I'd definitely run out of space. Okay? But what we see is as this guy goes to the right, it gets super big, super fast. As it goes to the left, it gets super small. And this is just going to keep getting smaller and smaller and smaller and get awfully close to 0, but never technically hitting 0. So this is an example of exponential growth. If I knew how to draw pictures correctly, this is going to look absolutely terrible. I'm going to start that over, pretend that didn't happen. Look at it. Look at it. Looks like a hair. Scooch it over there. Let's try one more time. Still staring at me. Let's make it nice, and yeah, maybe if I kind of do like a sketch way of doing this, nice and flat, gets bigger, gets bigger, gets bigger, gets much bigger, much bigger, much bigger, much bigger. And even though that still looks god-awful, that's what it is. Exponential growth. Don't judge me on my artistic talent. Judge me on my brain, which is slightly above average. But there you have it.